through the prereq scales diagnostic, and I will post this video on YouTube so you guys can watch it at your own pace, and then I'm going to post the solutions that I write down. All the solutions I'm going to write are going to be at the bottom of the page, or at the bottom of the document. So the first question says, factor completely and list all the real roots of this polynomial. So we'll go down. So question 1, I'll highlight it. So the question says 6x cubed minus 7x. Actually, I think I'll just copy. So this is what we're trying to factor. So we can use, without really knowing anything a priori, we can use the rational root theorem to try and figure out some roots. So using the rational root theorem, we know that the possible roots are factors of 15 over factors of 6. The factors of 15 are 1, 3, 5, and 15. And the factors of, let me put this downstairs. The factors of 6 are 1, 2, 3, 6. So it's going to be some, and then you can put a plus or minus, some ratio between these guys. So one of the options you can see here is 1 divided by 1. I'm going to try that one first. And then we can try that using synthetic division. So put a 1. Hopefully you guys remember how to do synthetic division. 6 minus 7 minus 14 and 15. So we bring the 6 down. 6 times 1 is 6. Negative 1, negative 1, negative 15, negative 15, remainder 0. How nice is that? So we know that x minus, or so let me say this, we know x equals 1 is a root, and x minus 1 is a factor. Let me put it downstairs. Now we just need to find the other factors. We can continue doing the rational root theorem, or we can use the quadratic formula, because now we know that the polynomial, we know that 6x cubed minus 7x squared minus 14x plus 15 divided by x minus 1. This is going to be equal to 6x squared minus x minus 15. And that's coming from this here. So now we can use the quadratic formula there. So a equals 6, b equals negative 1, c equals negative 15. Using the quadratic formula, we get negative 1 plus or minus the square root of b squared minus 4ac all over 2a. This becomes 1 plus or minus the square root of 1 minus, actually the minus makes it plus, 4 times 6 times 15. So this is, I'll use a calculator real quick. $360. Actually, so it'll be 1 plus 360 divided by 12. And then when we take the square root of 361, we get 19. So it's 1 plus or minus 19 over 12, which is 20 over 12, or negative 18 over 12. We could simplify those a little bit more, and we will get 5 over equals 5 over 3, or negative 3 over 2. So all the roots are going to be x equals 1, x equals 5 over 3, x equals negative 3 over 2 are the roots. And so the factors are roots. And factors are x minus 1, x minus 5 over 2, 5 over 3, and x minus negative 3 over 2. Okay, so now we can go on to number 2. Number 2 says, simplify this expression and state all the values that it's undefined. So I can copy that, paste, and we can simplify now. So on the top there, I see on the left-hand side I have a difference of squares. I can write that as x minus 3, x plus 3 over, I'll deal with the rest in a second, 2x plus 1, x minus 3. So I can already see that, 2 guys are going to cancel out there. That's very nice. Now let's factor the bottom. I know I have a 2 here, so it'll be a 2x, and then a regular x. I have a minus and a minus, so I know that I'm going to have opposite signs. So maybe I can do something like minus 3 and plus 1. Let's see. So if I do 2x plus 1 times x minus 3, I'll get 2x squared. I'll get plus x. I'll get minus 6x minus 3, which gives us 2x squared minus 5x minus 3, exactly as we need. So that works out nicely. And now, in fact, we can cancel out this guy and this guy. So we'll get, and then this guy and this guy, and we'll just end up with x plus 3 over x minus 3. Now the only places where this is undefined is where we divide by 0. But we can't just look at this guy here, we have to look at the whole original denominator, which means that we are not allowed to do, so can't input, or maybe I'll try undefined for x equals 3, that comes from here, and 1/2. Cool. And now we look at number 3. Express this inequality, or solve this inequality. Okay. So your first thought might be, okay, let's multiply both sides by x minus 4. But we don't know if x minus 4 is going to be positive or negative, and it requires us to do some thinking about that, like, okay, what situation would x minus 4 be positive? And the reason we have to be careful is because we switch the direction of the inequality if we multiply or divide by negative. So we want to be careful. So instead of maybe giving ourselves more mental work, instead what we could do is we could divide or subtract 2 from both sides, and we'll get 3 over x minus 4 minus 2 is greater than 0. Right, we just subtracted, we didn't divide or anything. Now, combine the fractions into 1, 3 over x minus 4 minus 2 x minus 4 over x minus 4. Simplify some more, we'll get 3 minus 2x plus 8 over x minus 4. This has to be greater than 0, but we can simplify one more time, and we'll get 11 minus 2x over x minus 4. This is greater than 0. So I know that I can't divide by 4, right? I can't plug in 4, and I got to figure out when is this equal to 0. So 11 minus 2x is equal to 0 means that x is equal to, let's see, I guess 11 over 2, 5.5. So now we will get that we can make a little number line here. I know at 4 I'm kind of undefined, so I'll put like a little dot here. F 11 over 2, it's equal to 0. So what happens in the other regions? So what if I plug in 5? If I plug in 5 into here, so I'll get x equals 5. Into here, I'll get 11 minus 10 over 1, which is, whatever it is greater than 0. So it's positive in this region because 5 is here. Now I look on the to the right. Let's plug in 6. X equals 6. I get 11 minus 12 over 6 minus 4. And whatever this is negative because 11 minus 12. So it's negative here. And finally, I look over here. So what if I was to plug in 0, let's say? All right, I'm just taking at test points here. So if I plugged in 0, I would get 11 minus 2 times 0 over 0 minus 4, which is negative because of the negative on the bottom. So I'll get negative over here. And so the only region where it's positive is here. So that means that the solution would be 4 to 11 over 2. And we don't include either of them because it was a, where is it? Right here. It was not a greater than or equal to, it was just a greater than. So we don't include it. And we don't include the 4 because that's an asymptote. Okay. Now we go to the next question. Last one in this section was rewrite this expression here. Copy. Paste. Okay. That was 4 actually. Okay. So here we use our log rules and exponent rules. So I have e to the ln. Remember that e to the ln is the same thing as e to the log base e. Make it a little bit bigger. All of that to the power of 1/2 of log base e of 5 times 10 to the log base 10 of 2. Well, using our log rules, we know that the e and the log will cancel out, and I'll be left with 5 to the 1/2 times 2, which is 2 square root of 5. And that's really all we do there. Now we look at number 5. I said the graph below defines a piecewise function. Write a piecewise, write a possible idea. So I'll put it on the floor there, or I'll copy it, and I will graph it. I'll make it a little smaller just so I can fit the rest. But we can notice here, it's basically a straight line here, and it's a straight line here. Here I have a positive slope, and here I have a negative slope. I have a y-intercept. We don't have any markings on what the actual numerical values are, so it's kind of just a guess. Whatever it is, though, it looks like the height here is about double the height here. So that means the y-intercept is going to be twice as high. And the y-intercepts are both positive, and we only are going to include on this guy. So one possible idea would be something like this. F of x is equal to, it's a straight line, so we're going to use y equals mx plus b. So my m is going to be positive for the left-hand side, so maybe something like 2x. And I'll put plus 1. That way the y-intercept is positive. And it'll be x is less than 0, because it's only in the negative portion we get that graph. Now we look at the, and we don't fill in the dot, or we don't include 0 because it's not a filled in dot. Now we look at the top function on the right-hand side. That's going to have a negative slope, so let's say negative 2x plus and 2, because we already said that the y-intercept looks to be twice as high. And that will be x is greater than or equal to 0. That's just one possible way to do it. Basically, any solution that has a positive slope, positive y-intercept, and then we include for the left hand, or we include on the right hand side, but not on the left hand side would work. It's just making sure that you're able to kind of visualize what the graph should look like. Okay, so now we look at the next guy. Oops. Okay. So the next one is like this. So first it says state the domain. So remember with square roots, I can't include, or I can't take square roots of negative numbers. I can take square root of 0, and I can take square root of values greater than 0, but not negative numbers. So that means we need 4x minus x squared to be greater than or equal to 0. We can factor here, and we'll have 4, or we'll have I'll factor an x times 4 minus x greater than or equal to 0. So, and now from here, what we have to do is, let's say, where is it equal to 0, right? Well, it's equal to 0 at 0 and at 4. So now we can test points in between. So if I was to plug in, let's say, -1, I would get -1, a negative number times a positive number, negative. If I was to plug in, let's say, 2, I'd get a positive, and if I was to plug in something like 5, I would get a negative. And you can check this for yourself. So that means that the only place where it's positive or greater than or equal to 0 is between 0 and 4. So for A, it's just going to be 0 and 4, and we're allowed to put in 0 and 4 because, remember, we can take the square root of 0. Now B, as for the range. Now this might be a little tricky, but it's not too horrendous, I guess. So we can think about this 4x minus x squared thing. Notice it's a parabola, right? 4x minus x squared is a parabola. And because it has a negative here, it's going to be a downward facing parabola, something like this. So I could find what the maximum value is, and I can find what the maximum value of this guy is going to be, right? Because if I know what the maximum value of my input is going to be, I know what the maximum of this guy is because the square root is an increasing function. So now we can look. So the maximum value here we use finding the vertex. So the x coordinate of the vertex is negative b over 2a. In this case, it's negative 4 over 2 times negative 1, which is equal to 2. So the x coordinate is 2. And the y coordinate would be what you get when you plug that in. So we get 4 times 2 minus 2 squared, which is 8 minus 4, which is 4. So the maximum value is 4. So now we know that the absolute height is 4. And I know that the absolute minimum is going to be 0 because that's the smallest value I'm allowed to plug in. So the range is going to be from 0 to 0. 0 to 4, I mean. So also for B, we'll get 0, 4. And we should be able to check this with Desmos. Now we look at number 7. Compute the average rate of change. As you guys remember from your homework, average rate of change is nothing more than basically the slope. So we would just plug in our endpoints. So because if we were to graph this, let's just say it looks like this. It doesn't really, but let's just say. I know that at 1, I get this point. At 4, I'll get this point. And to compute the average rate of change, I just draw the line between them. And I get the slope of that line. Well, the slope of the line is just the slope between the 2 points, which is going to be, I'll call it its h. So it's going to be, if you remember your formula, it's y2 minus y1, x2 minus x1. In our case, it's h of 4 minus h of 1 over 4 minus 1. H of 4 is 3 over 4 plus 1, which is 3 over 5. And h of 1 is 3 over 1 plus 1, 3 over 2. So now you would plug these points in to the formula, and you'll get, so I'll call it average is 3 over 5 minus 3 over 2 over 4 minus 1. And the bottom is going to be 3, and now we just have to combine the fractions. You can get a common factor of 10, so this would be 6 over 10 minus 15 over 10, which is 6 minus 15 is negative 9 over 10, which is negative 9 over 30. We can simplify that some more. and we get negative 3 over 10. And there's our answer. Next, for number 8. Let's see. Okay, so now we're using trig. So compute these guys exactly. So one way would be to just memorize the unit circle. And like I said in class, I'm not really expecting you guys to have the unit circle totally memorized, but it is good to kind of have an idea of the different values. So if you see a square root 2 over 2, you're not like, oh, what is that? It should be familiar to you as a trig kind of thing, for example. But let's say you don't have memorized, but you do remember your special right triangles. So that's going to be good enough. So we look at this sine 225. So we make our unit circle. Good enough. And 225, we know that this is 180, so 225 is going to be here. Now, because this is 270, it's halfway between. So now, what we do is we see, okay, this much is 180, and then this much is 45. So we can make a little special triangle here, where that is going to be 45. Maybe I'll make this a little thinner, and I'll make this a little larger. That's going to be 45 degrees, 90. And if this is 90 and this is 45, the other angle has to be 45 as well. And now if you remember from maybe high school geometry or something, you had a special right triangle, 45, 45, 90 triangle. Well, the sides would be 1, 1, square root of 2. And then we get that the sine of this guy is going to be, sine of the 45 will be opposite over hypotenuse. So sine of 45 degrees is 1 over root 2. Now, we know that it's in the third quadrant though, so it's going to be a negative y value. So for the first one, it's going to be negative 1 over square root of 2. And that's all. We can repeat the process with this cosine of 30 guy. Cosine of 30, I'll do this angle in blue, will be something like this, where this angle here is 30. Because remember, negative, we go backwards. So we can make our triangle again. So I'll do it like this. So 1, 2, 3. And now here, this one was 30. Make it a little smaller. And this is 60, and this is 90. And now again, if you remember, this is going to be 1, this is square root of 3, and this is 2. And the cosine of that, so cosine of negative 30 degrees would be adjacent over hypotenuse, square root of 3 over 2. And that's all. And now because we can check the sign, because in the fourth quadrant, it's on the right-hand side, it's going to be a positive x value. So we get here, we get negative, or not negative, I'm sorry. We get positive square root of 3 over 2. And finally with tangent. 5 pi over 4 is a little bit more than 1 pi, right? Well, and in fact, 5 pi over 4 is the same thing as 225 degrees. So it's the same triangle that we used originally. So if we were to take tangent of that angle, it would be 1 over 1. And because it's negative, because in the third quadrant, the x value is negative and the y value is negative, so we get negative all around. So we get negative over negative, we get a positive value. So for this one, it's just going to be 1 over 1, which is 1. And that's all you do for that one. It's basically just using the special right triangles. Okay. Next was this guy here. Prove or disprove this identity. So one thing I want to emphasize here, we can't start by assuming that they are equal, right? Because if you start by assuming they're equal and then you kind of show something, it doesn't really make sense. Because instead I could have written something totally wrong. Like I could have written 2 plus 2 equals 5 and start assuming they're equal and try and like do some random stuff to, maybe get somewhere. It doesn't make sense that way. You have to start off with one side and show you get the other side. So let's say we start off with the left-hand side. And I'm starting off with this side because there's more to work with, right? It's kind of more obvious where manipulations can go. If we start off with the right-hand side, all I have is a sign there. Like, what am I going to do? Obviously, right? If you already kind of have an idea of where to go, then okay. But on the face of it, we have no idea where to go. So let's instead start with the left-hand side. So on the left-hand side, we have 1 minus cosine squared of theta over sine theta. Now, I have 1 minus cosine squared. Hopefully you guys remember we have sine squared theta plus cosine squared theta equals 1. This is the classic Pythagorean identity. You should know this. Now, solving for, if we subtract cosine squared on both sides, we'll get sine squared theta is 1 minus cosine squared theta. And now this matches exactly here. So we can replace this guy with this guy here, sine squared, and we'll get that this is equal to sine squared theta over sine theta. Well, the sine over sine cancel, and we just get sine theta. But look at that. That's exactly what we're looking for. So we're all done. And like mathematicians do, we put our little square and fill it in. So we just show that this 1 minus cosine squared over sine is equal to sine. Great. Now we look at number 10. A 12-foot ladder leans against the wall. Let's just snip the whole thing and then we'll talk about it. Okay. A 12-foot ladder leans against a vertical wall. So let's start by drawing that out. So we have a ladder. So I'll call this L for ladder. We have some wall like this, W for wall. And this is the floor, I'll put G for ground. Write an expression for the angle theta between the ladder and the ground. So this would be theta here, because ladder and ground. If the base of the ladder is 5 feet from the wall, so that means this length here is 5. Okay, so I'm looking for that. Oh, and we know that the ladder is 12 feet tall, so I'll replace the L by 12. So I don't know what the height is, right? The W of the height of the wall I don't know, but the length of the ladder that I did know. So they're asking for the angle theta. Well, we know that using our trig functions, we could say that cosine of theta is going to be adjacent over hypotenuse, which is 5 over 12. Taking the cosine inverse to solve for theta, we get theta equals cosine inverse of 5 over 12. And that's all. That's all we'd have to write for A. For B, I'm not going to do this because this is just plug into a calculator. But you should get some reasonable answer, I guess. Now we look at number 11. Determine whether this function is even, odd, or neither. Okay. So if you guys remember, for even, this means that f of negative x equals f of x. And then for odd, this means that f of negative x equals negative f of x. So we plug in negative x and we get the negative out. We plug in negative x and we get the original thing out. So we just need to check are either of those conditions met. So we plug in negative x, and so f of negative x in our case, or I guess it's p actually, so in our case it's p of negative x is negative x to the 5th minus 2 negative x cubed plus negative x. Negative x to the 5th is negative x to the 5th. We have minus, so the negative x cubed becomes negative x cubed. The negative becomes a plus x, 2x cubed. And finally we have the plus negative, which becomes minus. I can pull a minus out of everything, and I'll get negative x to the 5 plus minus 2x to the 5th. I'm sorry, 2x cubed plus x, which is negative p of x. So thus it means odd. Now, when they talk about reference to symmetry, so if we just did it algebraically, reference to symmetry would mean if you were to graph this out, what would it look like? And if you were to graph it out, you should see that it's symmetric around the origin. And I'm not going to do that here, but you could do that on Desmos. Almost done, guys. Here we have number 12. Let me grab the functions. So it says first find g of f, and then tell us if f is invertible. Okay. So g of f of x is equal to this. So we just plug in f into g. So it would be the square root of 2x plus 3 minus 1, which is square root of 2x minus, oh, it's 2x plus 2. And you can simplify a little bit more if you'd like. Square root of 2 times x minus 1, but that's not really necessary. And although this is just g of f of x. Now we look for, oh, I'm sorry, that's p plus 1. And now we look at the next question. It says, is f invertible? So one condition that will tell you if something's invertible is if the function is called 1-to-1. So basically it's saying, is f 1-to-1? So this phrase might seem a little alien to some of you who haven't heard it before, but basically it just means for every y value, is there just one x value that gets you there? So if we look at something like this, right? I have a y value here, the same y value, but 2 different x values would have gotten me that function value. If I look at something like this, for example, though, for every single x value, for every single y value, there's one x value. So one way you could test that geometrically, like visually, is with something called a horizontal line test. So if we go back to what we just did, you can see if you make a horizontal line and it passes through more than once, horizontal line test has failed. Here, the horizontal line test passed because it only crosses the function once. So that means that straight lines are 1-to-1. Now we look at our function here. F is a straight line. It's y equals mx plus b. So since f is 1-to-1, we can say yes. So that means yes, invertible. And then to find it, so right now we've got y equals 2x plus 3. We swap the x and the y's, so we get x equals 2y plus 3, and now we just solve for y again. So we get here x minus 3 equals 2y, or y equals x minus 3 over 2. And that right there is your inverse. Cool. 13. Oh, second to last one. Population is modeled like this. Okay. So t is the number of years since 2020. Interpret the meaning of the constant 0.04. So 0.04 is going to somehow scale our time. So how can I phrase this effectively? One way to think about it, well, actually, let's do number b first, and then we'll go back to a, because this is more of a computational thing versus a interpretation thing. So if we look at b says, when is the population going to reach 250,000? So population is the p of t. So we would just plug in 250,000 for that one. So I'll put b here. 250,000 equals 150 e to the 0.04t. Divide both sides by 150, and we'll get 250,000 over 150 equals e to the 0.04t. And then we get that, I'll use my calculator real quick. 250,000 divided by 150 is equal to 1,666.6667, basically, approximately, equals e to the 0.04t. I have an e here, so I need to take the natural log to get rid of that. So we take the ln of this, so 1,666.667 is equal to, we take the ln, the power goes down, 0.04t, oh, extra 0. And then divide both sides by 0.04, so I'll put 1 over 0.004 ln, oops, I put an extra t again, I'm sorry, an extra 0, 1666.667 equals t. And now we use our calculator for that. Divided by 0.04, we get approximately 185 years. Cool. Now, we know that, so that's our answer for B. For part A, they're saying, okay, what does the 0.04 kind of mean? What is the interpretation? So if the t tells you how many years have passed, right? So if t equals 1, it's 1 year passed. T equals 2, 2 years passed, and so on. So in theory, it should be that every year, the population changes, it's it gets multiplied by e, essentially, because e is my growth rate. But instead of every year, I have to scale by the 0.04. So it kind of scales how long before I kind of multiply by e, my population. So I have some initial population 1, this will get multiplied by e, and I'll get population 2, and then I'll get multiplied by e again, it'll be population 3, and so on. So for every time I multiply by e, the population grows, right? But like if this was like 100, it'd be 100 times e, and then 100 times e squared, and so on. But since I have the 0.04 there, it's not that 1 year passes, and that would get me multiplication by e. It would have to be a larger quantity. So it kind of slows down our growth, if that makes sense. So, and now finally we can go down to, I think this is 14. Without formal calculus, explain why this approaches a finite value. Well, we already kind of covered this in class a lot when we talked about limits, but we can talk about this a little bit. So we have here x squared minus 4 over x minus 2. We have x squared minus 4 over x minus 2. If I was to plug in x equals 2, I would get 2 squared minus 4 over 2 minus 2. I get 0 over 0. Well, as we know, we don't like that. So we don't want to kind of just accept that as the answer. And normally you would see 0 over 0 and you freak out and you're like, oh my gosh, it's undefined or something. And yeah, we can't plug in 2, but we can see kind of what happens as we get closer and closer. So as we get closer and closer, one way to do this is to plug in values closer and closer to 2. So if we were to do that, we would get, values that possibly approach some value. The y values will maybe approach something. Another way to kind of see that, though, if you don't want to plug in values like using calculator, is to notice that we have a difference of squares up top. This is x minus 2, x plus 2, over x minus 2. The x minus 2's cancel, and we'll just get x plus 2. And now if I was to plug in 2, I have no problem, right? So without kind of even having to plug in close by values, I could simply plug in 2 into my simplified version, and I would get 4. So the x values, as they approach 2, the y values should approach 4. And we can check this using a graph, like Desmos. Hopefully that this whole packet made sense, and I think that we're going to call it here. Let me know if you guys have any questions.